So I just wanted to check.
I got you. That's a good place to start. All right. Pop. All right, so there's good old chapter 1. So if you go to the end of chapter 1, one good thing to notice is there are some answers to the questions. Don't just copy. There are typos in here. Makes it so much easier for me to get people that are just copying shit. So don't do that. You can check your work. It's not a bad idea. The answers are there. Yeah, check your work. Have faith in yourself, though, more than the book, because there are typos in there. So here is 1 through 5. Here's where the stuff starts. So like I told you, they have 2 sections. Practice, and then another one they call homework. Unfortunately, I didn't like all the problems in the homework. I needed to assign some from the practice also. So that's why you see problems from like number 1 and then number 40. Right? You just do those for section 1.1 and so forth. You guys with me? So here's 1 through 5 from the homework. And it relates to this whole setup here. So I'm going to have to go to the previous page to start reading what it's all about. So it's about researchers looking at people that have the AIDS symptoms showing, and then taking some treatment. Okay? You guys with me? So Jackie, you're talking about examples from the section?
Yeah. 1.2.
So that's one thing I would certainly hope they would update is so you know where the hell you are when you're in the middle of the book. All right, here's 1.2. So you're talking about which problems here?
1 through 5.
This year?
I think so, yeah.
Oh, I see. Determine the following, whether or not the following samples are representative. I like that. To find the GPA of all students in a university, use all honor students at the university as the sample. No. Why is that not good? In fact, not only do we think it'll be biased, we know exactly how it would be biased. It would be skewed way high, right? There are honor students for a reason. You guys with me? I mean, that's almost too obvious to just believe. Find out the most popular cereal among young people. I love this. Not the old people under the age of 10, just the young people under the age of 10. Stand outside a large supermarket for 3 hours and speak to every 20th child under age 10 who enters the supermarket. You gotta love this. Does that sound okay? Do all kids go to the supermarket with their, it sounds like they're alone. Excuse me. Yes, I must go buy some groceries. How old are you? 3. So that's no good. That's actually, believe it or not, is a convenience sample. You made no attempt to make sure you represented the population. You're just getting people that happen to come into the supermarket. Okay. And so forth. I don't know. So I think, does it sound like they all have a problem? Is that what you think?
I just got confused.
All right. Now, some of this we haven't talked about yet. We haven't talked about the different types of sampling.
Mm-hmm.
I don't think we haven't talked about cluster sampling and stratified sampling. No. So that's part of it. Is the next one talks about cluster sampling. And then you're like, what? Is that some kind of cereal?
Yeah.
Honey nut clusters? No. Okay. So anything else from homework stuff? Yes.
On the 1 through 5, I'm a little confused on the sample and population. So is the population AIDS patients, and then the sample is the ones that treated?
So what do you think the sample was? The population. So here's what's really cool. Very often you can identify the sample real easy. It's just the people they talk to. So if I said I talked to 47 gross 1 students majoring in statistics, then what's my sample? That's just what I just said, right? I have to tell you who it is I'm looking at. So what's the population? You can almost always replace the number with the word all. 47 gross 1 students majoring in statistics. What's the population? All gross 1 students majoring in statistics, right? So it's very often I say find the sample first, because that's almost, they have to tell you that directly. And then you can kind of just generalize that. So if I said my sample was 3,000 people from the west coast of the United States, what's my population? Is it everybody in the U.S.?
Yes.
You sure about that? If my sample was 3,000 people from the west coast of the United States,
All West Coast.
then my population would be all people on the west coast of the United States, right? Why would my sample suck if my population was all people in the United States?
Because that's from the south.
Yeah, I highly doubt that I've randomly picked only people from the west coast if my whole population was everybody in the U.S. I didn't do a very good job of randomizing. Maybe I just picked people as I drove from San Diego to Vancouver, which is a beautiful drive, by the way. Yes, and then we're going to do another example that I was planning on doing, but this is sort of leading in that direction. Let's do the example I was thinking about. All right, let me make sure what I signed so I don't do homework for you. 44, okay, let's do 46 maybe, yeah. There's 46 up there at the top. Can you guys see it? And this asks you, identify A, B, C, D, E, F. I need A through F for each problem. It's not a multiple choice. For each problem, you identify all of these things. You guys with me? Very often now people turn this in and they just say, sample. No. It's what is this? So here, this is a little tricky. They give you something, they don't tell you what the sample is. So when you get to the point where you have to say what the sample is, you can either just say a subgroup of whatever the population is, or 87 randomly selected. You know, they say give examples where appropriate, so that could be one place you use an example. Here's how I would pick a sample. It would be 87 randomly selected people, blah, blah, blah. Okay? So number 46 says, a politician is interested in the proportion of voters in his district who think he is doing a good job. So what's the population? Who are the people he wants to say something about? Who? Say again?
The voters in his district.
The voters. In fact, be really even more, all the voters in his district, right? Now, what's wrong if I say all the voters in his district who think he's doing a good job? Why, if I say that's my population, why does that make no sense? Yeah, automatically, what's my percentage going to be, no matter what sample I pick? If my population is everybody who think I'm doing a good job, every sample I pick, I'm going to get 100% that think I'm doing a good job, right? That sort of sounds like what, Trump might request. But, let's not go there. Politics, shit. So the population is definitely all voters in his district. You can't make it more specific because if you just make it people who think he's doing a good job, you're always going to get 100%. That makes no sense. So that's what I'm trying to say about that group, the percentage who thinks he's doing a good job. The group is all voters in his district. What would the sample be? Give me one way to say the sample. Sure, one way to say it is a subgroup of all voters in his district, right? A subgroup of voters in his district. Or you could say 300 randomly selected voters in his district. It's up to you. Both ways are acceptable. Do you guys get the idea? Some of you guys look so dejected. I'm sorry. Give it a chance. Don't give up immediately. Okay. Let's see. And then they want the parameter of the statistic. Parameter of the statistic. Yeah. So however you worded the population, however you worded the sample, you just use that same language here. So what is the parameter going to be? It's almost always a mean or a percentage. So in this case, it's obviously a percentage. That's what proportion means, percentage. So the parameter is the percentage of who? Good, now make it more specific. The percentage of all voters in his district that think he's doing a good job. Now you bring that in. Because just to say, if I just said, I want to know the percentage of students in this class, that what? Do you see what I'm saying? I always get that. The percentage of voters in his district, that doesn't make sense. There should be more to that. The percentage of those voters that do what? That think he's doing a good job. Because what's going to happen when you take a sample? You're going to get some people that think he's doing a good job. You're going to get some people that think he's doing a suck-ass job, so forth, right? Or whatever adjective you want to use. Technical word is suck-ass. And then, so the parameter is the percentage of all voters in his district who think he's doing a good job. What's the statistic going to be? The percentage of the subgroup of voters, or the percentage of the 300 selected voters. Because what's a parameter describe? Population. So you get whatever the population language, you use that to describe the parameter. Statistic describes the sample. So however you said the sample, that's going to show up when you describe the statistic. Let that make sense? And then they ask for the variable and the data. Who remembers what the variable is related to?
Numbers.
The question that's going to be asked, right? So if you think, you got to think about what group of people you want to say something about, what group are you going to work with, what do you want to say about everybody, what are you going to say about this group, and then you're going to be like, well, what the hell are you going to ask the group? Once you get them assembled, you better ask them something, or at least look at something. So what's the question that you want answered?
Think that he's doing good?
Yeah, do you think that he's doing a good job? That's the variable. Whether or not they think he's doing a good job. Now, the data is going to be the answers to that question. So what possible answers are there to that question?
Negative or positive.
Well, sure, but fundamentally they break down to yes
It's very good.
or no, right? You guys with me? A little bit, yes?
Will you reiterate the statistic of this?
Yeah, so the population was, just real quick, the population was the percentage of all voters in the district who think he's doing a good job. The statistic is going to sound just like that, except it's the percentage of the sampled voters. So the subgroup or the 300 voters, if you just picked an example, sample size, it's up to you how you want to word it. The percentage of, put sample here, that think he's doing a good job. Parameter is the percentage of, put population here, that think he's doing a good job. Are you with me? And the statistic is the percentage of, put sample here, that think he's doing a good job. Yes, ma'am.
So the data is the possible outcome?
Yes. So in this case,
It's not a number like the actual results.
well, data could, like we found out the other day, data can be qualitative or quantitative. So it could be words or numbers. So in this case, I kind of disagree. If you look in the answers, they actually say the number of people, but that's not the data. That's what you do with the data. What's the actual data? Yes, no, yes, yes, no, yes, 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 no. And then what do I do with the data? I count how many people said yes, and then I can make a percentage. So I kind of disagree with the book, but oh well. Can't always be right book. Yes?
I'm sorry, I didn't get the statistic.
So the population was the percentage of all voters who think he's doing a good job. The statistic would be the percentage of the subgroup of voters, or however you worded the sample. The percentage of the sampled voters who think he's doing a good job.
I thought that was a parameter.
Parameter is the percentage of all voters who think he's doing a good job. The statistic describes the sample. That would be the percentage of the sampled voters.
Can you do it in a
You ready?
circle?
You ready? You're all my population. And I want to say the percentage of you guys who are older than 25, right? Then I take this row, and I ask you how old you are, and then I can figure out the percentage of this row that's over 25. That's my statistic, the percentage of this row that's over 25. The percentage of everybody who's over 25 in this room, that's the parameter.
Oh, so you're not testing everybody, so you're just choosing a part that you're
Exactly.
testing.
In fact, normally the population is way too large for us to
To be testing
get a hold of, so we
everybody.
almost always work with a sample.
Okay, I got you.
I like it. If we had all the population data, that's such a weird place for a statistician that they're like, oh shit, there's not going to be any plus or minus shit anywhere. I'm going to know exactly what it is. That's a really weird place to be as a statistician, is to have all the population data. You're like, oh my God. You guys all right? Just, if you haven't noticed, this first chapter is very wordy. There's a lot of, it's nothing but definitions. I try to warn you going in. And it was nothing but definitions. So you just got to kind of slog through it. But we got to know what these words mean when they come up later this semester. Chapter 2, we're going to get some math and some computation stuff to sink our teeth into. Which some of you guys are like, that's okay. We're going to get there anyway. All right, anything else from homework stuff?
So it's due when we finish this.
Yay. So just to know you're on track, when I finish lecturing on something, you really should be done or close to done with that thing 2 classes later. Like today I'm going to finish chapter 1 and get into chapter 2. I'm hoping to get through 2-2. You're like, whatever, Jeff. If I do that, then a week from now, if you're almost done with 2-2, you're on track. If you haven't gotten to chapter 2 yet, you're behind. When is the homework late? After the test. So you always have until the day of the test. But I try to give you this idea so you don't do the thing where you try to do it all the day before the test. I've done that, trust me, and that's really, really stupid. You guys have done that too, I know, and you know it's really, really stupid, so don't do that. Okay. Some of you guys are like, that's the only way I operate. I'm like, did you try the other way? Okay. Anything else from homework stuff? Or technical stuff or anything? Okay. There's a few definitions left to go over. I'm going to leave section 1.4 for you guys to read. Ha ha ha. So there is homework in 1.4. And just to warn you, when you do the homework in 1.4, you have to use the terminology in section 1.4. So I'm going to try to force you to read some of the book. Okay. So we're going to talk about the cluster stuff that came up earlier, the types of sampling. Work with me. Okay. Oh, maybe I'll need that. I'll leave that up here. Anybody seen the videos online yet? Looked at those? You don't have to. They're just there in case you want them. So I'm going to post videos after every lecture. Turn on the captions. Sometimes they're funny, what they think I said. So types of sampling. So the first type is kind of the ideal. Other types we're going to talk about are actually this too. They're just more specific ways to get here. The ideal sample, and we keep using this word, and a lot of people that post to YouTube don't have a clue what random really means, but random sampling. Right? Random sample. And I think we finally figured out what makes something random, didn't we? What makes it truly representative? What would be a random sample? Good. Everyone in the population has the same chance to get into the sample. I like it. All items in population, so it could be people or shoes or salamanders or whatever. All items in the population have an equal chance.
Rewrite that again.
If you want to get in the sample. Okay. Like it. Then we have this one. Let's do systematic first, because the next two are kind of like based off each other. Systematic. Systematic. I like it. So systematic kind of sounds like there's a system to it. So that's an early example we're talking about with Jackie here. Every nth thing, or like if I go take the temperature every 30 minutes, every nth minute, there's a system to it. If I take every 7th thing off the assembly line, if I take every 20th kid that comes into the supermarket, I don't take them, don't I? I learned something about my teacher. No. So systematic is every nth something. It could be every nth minute, every nth thing. every nth car that goes by, every nth song that comes up on the radio. Is it very cool with me saying nth? Every fifth, sixth, seventh. So if I don't want a specific number, what do I use? Nth. Every nth. I feel so bad for you guys trying to read my writing. Every nth thing is sample. So if every 20 feet I took a sample of dirt to see what the conditions were, that's a systematic sampling. Now, to make it truly systematic, you might wonder, if I took every third person, somebody might think, well, that's not really random because the first guy had no chance to be in it or something. But I start with a random, so I randomly pick the first person and then every 3 people after that, every third person after that. Do you guys see? So does anybody not have a chance? No, everybody's got a chance. Now, some people get confused. They're like, well, if I started with you, and then 1, 2, 3, they would say, well, she didn't get into the sample. No, did she have a chance? Yeah. Because I started randomly, right? I could pick like the number 1 through 8 randomly, and that'd be the first person I start with, and then every third person after that. Everybody had a chance. Are you guys with me? Where does systematic not work well? Anything that's cyclic, like the assembly line thing. There could be some assembly line. I always think about, I watch too many cartoons or something, but it would like turn and ka-chunk, and turn and ka-chunk, and turn and ka-chunk, and like the fourth one, it's broken, right? So if I took every 4th thing and I get nothing but broken thing, I'm like, the whole thing is shit. 100% defect. Or if I picked every 4th thing but I started with a good one, I would never get any bad ones. I'm like 100% good. Everything's great. So you don't want to use systematic in certain situations where there's something that might be happening in a cycle, right? But otherwise, it's a pretty good way to do things. Okay. All right. And then the next 2 are kind of related to each other. One's called stratified, and the other one's called cluster. They both start the same way. They both say break your population into groups. So this would be like, you're all broken into rows, right? And I'm going to count everybody in the back as their own row. So you're all in a row, boom. You with me? Some of you guys don't really line up with the row. Everybody with me? So both of them would start, they break up the population into groups. So they would both have the same first step. Stratified, it's like strata, I don't know, sort of related to that, but not really. Stratified says it's going to take sum from all. Notice that the stratified starts with the sum from all. It's nice. So it would take maybe a few from there, and a few from there, and a few from there, and those would all be my sample. So sum from all. That's stratified. So if I said, I'm going to take 3 people from every row, including the back row, I'm going to take 3 people from every row, that's stratified. Did everybody have a chance to be in it? Of course. Who wouldn't? Which people would not have a chance to be in? Everybody have a chance to be in, right? If I randomly took 3 people from every row, every person in here would have a chance to be in the sample. Are you guys with me? Everybody agree with that? I could have gone insane. I could be wrong. I'm pretty sure I'm not. Okay. Cluster says, I'm going to randomly pick 2 of these, right? And I'm going to take everybody. So if I randomly took 2 rows, you and you, and I took everybody from those rows, that would be my sample. That's cluster. Did everybody have a chance to get into the sample?
Yeah.
Hell yes, because I could have picked any damn row. I randomly chose rows and took everybody from those rows. Don't go, well, you didn't take her. No, the sample's not going to be everybody, but did everybody have a chance to be in the sample? Yes. You with me? If I said, that row's too far away, I'm just going to pick from the... No, that's not random then. They didn't have a chance. So there was, very quickly, there was a student of mine who was a veteran. He was in the Iraq War, and he said there was a company... Well, first he said cluster is shit. I was like, can you elaborate? He said, there's a company that went out to analyze the conditions in neighborhoods in Iraq after, like a year after the fall of Baghdad. So they went in there, and come to find out, I looked it up and I did some research. They only picked, so they broke Iraq up into regions, and then they only picked regions that were safe. And then they went there to see what things were like. So of course, will you trust their report? No, because they avoided the unsafe places where the neighborhoods probably had some problems. Are you with me? So it wasn't Cluster's fault. It was an inappropriate use. That was like I was saying, you guys are too far away, or man, it's too dangerous over there, right? Then not everybody had a chance. I can't trust your results. I can't trust them. Maybe. All right. Okay. The last one is bad. What's the last one? This has come up a couple times. What's the bad way of sampling? Convenience, right? So like if you were a sample that was supposed to represent gross flow, we've already talked about why that's crap, right? Not that you guys are bad, but you would be a bad sample. You are not representative. So convenience, I'm not even going to write anything down there. Kind of gives itself away. So if I said I took every third student that came to my office to do it, unfortunately not every student comes to my office. Even the ones that need to, they don't come to my office. And I'm out there sitting all alone. All right, so those are the types of sampling. So the kind of problem you're going to see from me is, I'm going to give you a situation and I'm going to say, identify what kind of sampling was used. Right? So if I said somebody at high school picked 40 seniors, 38 freshmen, 27 sophomores, and 13 juniors to be in the sample, what type would that be? Stratified. Cluster would mean I took every sophomore and every freshman. Just randomly picked one of the four groups that I took everybody. That would be cluster. I took some from each. Some from each, stratified. Cluster is all from some. So it sounds like some weird Three Musketeers thing, but some from all and all. Yes?
So not stratified, is not the same amount.
I like it. So if there were 600 seniors at a high school and there were 300 freshmen in a high school, you might take double the seniors. You might take 20 seniors randomly and 10 freshmen. You could do what's called proportional sampling based on the sizes so that you have good representation. You don't have underrepresentation. It's sort of like our houses in Congress, to be honest. The Senate and the House of Republicans. Don't worry, I'm not going to turn this into a government class. Don't want to. Does that make sense? Yeah, okay. All right. Okay. So you just got to try to work with those to get used to the words. Okay. Now there's a whole thing in here. Well, it's going to come up right now, so it'll be easy enough to do. They do something in section 1.3 called frequency tables, and it comes up again in chapter 2. So I'm just going to do it all at once with chapter 2. So it's the same stuff. Okay. Chapter 2, like I said, is where we finally get into a point where we can start working with some data instead of just talking about how we're going to talk about it. It's like, oh my god. So we got this. All right. So the first thing we're going to do is a really quick little way to gather your sample data and to even sort it. Next Monday, we're going to be working with calculators. So if you have the TI or are going to get one, try to get it by Monday. I'm going to bring a little bag of calculators, but there's not like a ton of them, so don't bank on me having one for you. You understand? So if you want to play along, you want to get a calculator. Right? You can get them from the library. You can rent them from that website I showed you. You can steal them from a friend. Yes?
Can we rent them from the library?
Rent them? No, you can check them out.
For like a day or something?
I can't remember how long you can check them out.
For a
A
week.
week.
A week, okay. There you go. That's not too bad. I have no idea how many they have, though, so, hey. So, chapter 2 is really what's called descriptive statistics. And the other kind of statistics we're eventually going to get into is called inferential statistics. What does that word infer mean?
Get a reference from.
Good, yes? Yeah, kind of like make a guess. You can infer, like, I can infer from the way you were driving that you're drunk. You know that. I wasn't there watching you drink, but you certainly seem to be drunk from the way you were driving. So it's sort of like making a guess, but it's you can infer something about somebody or something. Okay. So inferential statistics is where we're going to take sample data and then try to say something about the whole population. And the way that's normally done, if you've ever seen like polls, like for elections really, and they'll say candidate A, looks like 44% will vote for them. Candidate B, it looks like 46% will vote for them. And at the bottom it says, plus or minus 4%. Right? Have you ever noticed that at all? No? No? You guys are like, I'm not going to answer that question. Okay. We're going to learn later how to calculate that number, that plus or minus 4%. We're going to be able to calculate it for ourselves. But that's inferential. I can't say for sure what the whole population is going to do, but I did take a pretty good sample so I can guess. I can infer what the whole population might do. There's a chance I'm wrong, though, and that's the plus or minus 4%. All right, so that's going to be later. This is descriptive statistics. So you take a sample, and you immediately just want to show people what your sample looks like in whatever way. So it could be demographics, or it could be whatever I'm studying about the sample. So the very first, most basic way to do this, there's a thing called a stem and leaf plot, believe it or not. Stay with me now. So stem and leaf plot, that's like, what the hell? Am I going to draw a tree? What is this? So let me give us some data, just make up some data here. So 21, 25, 27, 40, 41, 45, 46, 51, 54, 59. I like it. Okay, let you write that stuff down. Can you crank that other light on? Let's see what happens. Try the other way. Crank it on. Interesting. Don't worry. It's okay. Oh my gosh, now we're screwed. Okay. All right, get away from it. That's some freaky switches. I'm sorry I made you do that. That is not your fault.
Nope.
That's a psychological experiment. I got cameras in here somewhere. All right, so stem and leaf. Now, I was kind of nice here. I put it in order. I didn't really mean to, but I wasn't even thinking about it. Stem and leaf could be a way to order your data. Because what you're going to do is you're going to focus on the groups. So this naturally kind of breaks up into 20s, 30s, believe it or not, 40s, 50s. You don't skip somebody in the middle just because there's nothing there. It's got to be a part of your visual representation. It's got to show there's nothing here.
You gotta put 0.
Don't put 0 because then that would mean something. So the 20s, that's a stem. That's the stem. Now the leaves are the second digit. 21, 25, 27, 30, nothing here. And now if you put a 0, that would mean
30.
30. So don't put a 0.
Oh, I thought you meant like the 40.
Yes, now 40, 41, 45, 46, and then 51, 54, 59. I like it. So if your data was not in order, this would be kind of a way you could get it in order quickly by hand. We are going to learn how the calculator can order this stuff for us, right? That it costs enough money, you should be able to put numbers in order. And it can, thank God. Now, next to this, you have to put a key, because this could actually mean 2.1. This could mean 2001. This could mean 0.00021. So this right now could represent a lot of different things. We know it represents this, but we're not going to show this to people. We're going to show them this. So I got to put a key next to it. little key, a little way to, and don't write something for each element that kind of defeats the purpose. You put something like 2 line 1 means 21. And now I know how to read the whole damn thing. So I put a scale on a map or something. Okay, I like it. Not too bad, right? So if my data was 2.1, 2.52, it would look exactly the same. It's just my key would be 2, 1 means 2.1. That's kind of awesome. That's awesome. All right, stem leaf. Easy shit. I do have a handout today that makes it a little bit more interesting. All right. Now, if you're looking through the book, we don't do, what else do they have in here? I'm not worried about line graphs, really. I think I might have made you do something with a bar graph, but that doesn't really count. A bar graph, uses qualitative data. What kind of data is qualitative? Name data. So, for example, a bar graph could be the type of cars I see: Toyota, Ford, Hyundai, right? And so this would be a bar graph. Some bar graph possible from, and then this scale could be like number of cars or whatever. Okay, the make and the number of each. You with me? That's a bar graph. Why is there a gap here? Why does that not matter? Because that is the Toyota bar. That is the Ford bar. And in my hand, I got this bar where people go, that want a Ford. That's all. You want a Toyota? Get out of here. And the Hyundai bar. Right? That one sounds, I don't know if I want to go to the Hyundai bar. I don't know. You guys with me? If you have a Hyundai, I'm sorry. I didn't mean anything offensive.
Number what?
Huh?
What is that?
Number of cars?
Oh.
Yeah, the number of cars, the number of Toyotas. The height of the bar tells you how many of that thing is, and the label at the bottom tells you what it is. So gaps are allowed here, because do you think I'm missing something just because there's a gap? No. I got other Toyotas, I got other Fords, so forth. If I have quantitative data, numerical data, a gap would mean nobody was in there. So you can't have a gap everywhere. You can only have a gap if there actually is somewhere that had nothing. Qualitative data, they're distinct. They're discrete. Right? Okay, so we're going to focus on the latter. We're going to focus on quantitative data and how to create a graph for that. And it's what's called a histogram. No, do I need you? Not yet. Check. So, first we'll start off with the idea of a frequency distribution. This is really a tally chart, you know? When you look at tally. So, for example, let's see. If I had, let me make one and see if you guys can read it. If I had something that looked like this.
Send numbers through that.
I'm going to put this word up here, frequency. Or I put it there, but let's see if you guys can figure out what this means. Let's see, these are ages of people who are buying their kids' cars or something, right? So what do you think this column here would mean? Yeah, so this means there are 4 people between the ages of 40 and 44 that are buying the kids a car. Does that make sense? You guys see how to read this? So then if you're able to read this, you should be able to construct it from a list of data. I can give you the ages. We need to talk about how the hell do you set these suckers up? How wide would you say the classes are? How far apart are they?
Five.
Ooh, I guess they're 5 apart. They are. They really, really are. 40, 41, 42, 43, 45. No, I'm joking. That's not really mathematical. I'm sorry. But you see the width here. 5, 5, 5, 5. So why doesn't that say 45 then? Because if it did, where the shit would I put a 45-year-old? You can't get 2 homes. It's not fair. I'm 45. I only get 1 home. All right. You guys with me? Getting used to the fact that I'm 45. So we still have to talk about how to do this ourselves, but I just wanted you to see what the parts mean first. So this is not the best way to show somebody how things break out. All right, what's the best way? What have we humans created for showing how big a slice of the pie certain groups get?
Charts.
What's a part of that chart? If you think about a pie chart, what's it mean if it's this much? It's a certain percentage. So percents, ratios, right? It's in statistics we call it relative frequency. Because that's really what a ratio is. It's relative to the total, how many are in this one place. So there are 4 in this class out of how many total?
$64.
10, 21, 23, 24. Right? There's 24 total. You with me? 24 total people. There's 4 people there, 6 people there, 11 people there. Right? So what percentage are in this first class? 4 out of... Is that right? Let's see what I remember that stuff. So 45 by 24 is 0.1666. Well, just trust me, do it. You never know, my brain just had lunch. Okay. Yeah, exactly. You better know how to go from decimal to percent, because it's going to happen a lot here, right? In fact, just to live in the world, you should know how to do that shit. Real quick, think about percentages. If there was a 40% off sale, and they said, we'll take 60% off on top of that, is it free? Hell no, because it's 60% off of the lower price, which is not going to take it all the way down to 0, is it? So people really don't understand percentages. It's crazy. And there are some stores that take advantage of that on purpose. Right? Okay, so just, you should know how to do percentages. What about this one? 6 out of 24, that's a nice one. 25%. 11 out of 24, not so nice. 45.8. And then 2 out of 24. 8.33. So 8.33%. And then 1 out of 24. 4.6. What is it? 4.17? Yeah. Okay. Now, if you round, this won't come out perfect. Theoretically, these should all add up to be 100%. If they didn't, I left somebody out. But they could also round up, they could add up to be 99.9 or 100.1, because I might have rounded one direction more than the other. The way I've got it written, I don't know.
That's 831.
Say again? 8.33%? Yeah, a little percent symbol kind of blew up there on me. 100%. Neato, okay. It doesn't always have to be exactly 100. It depends on how you round. You guys with me? So it doesn't mean you did something wrong. If it comes out to be 95% or 103%, that's a little too far away. You did something wrong. If it's 100.2% or 99.7%, that's close enough. How you guys doing? You guys all right? Okay. You guys all look tired. Everybody ate lunch right before this, I guess, right? It's always the roughest class to get through. Oh, 1, 2, split it.
See.
Okay. So constructing this kind of thing really is not difficult. It's getting used to how to create these guys. That's the real problem. Once I get these done, I just count how many's in there and then make a ratio. Oh, okay. Not a big deal. So let's talk about how the hell to do this. Can somebody tell me what the lowest age most likely was?
Are we still using that?
40. So it could have been anywhere from 40 to 44. Normally, we're going to start at the first data point. Now, is the oldest person necessarily 64?
No.
No. Right? They could have all been 60. One guy. That one guy could have been anywhere from 60 to 64, right? You guys with me? Okay. But the data sort of ranged from 40 to 64, roughly. I like it. Now, if it would have went from 40 to 80, and I wanted this many classes, would they have been just as wide as they are now? If it went from 40 to 80, and I just wanted to have 5 classes, could they possibly be 5 wide? Obviously not. This doesn't make it far enough. They'd have to be a little wider because they got further to go. So what goes into figuring out how wide these are is, well, how far does your data go? And how many classes do you want? Right? These are called classes. Right. So let's figure out how to do that. Let's see, maybe we can use this data here. I've already got it sitting here. So if I had this data from earlier, and I wanted to know how wide the classes should be, well, how far does my data go? Sorry, say it again?
21, 59.
Yeah, 59. Well, I want to know the exact distance it goes. So I'm going to take no. If I want to know how far apart two numbers are, subtract. Yeah, so that would be 38. And now think about this. If I know how far I want to go, so for example, if I had to go 10 feet and I want to take 5 steps, let's just say I'm OCD. I've got to go 10 feet and I want to take exactly 5 steps. How big should each step be? Okay. How far I got to go, divided by how many steps I want to use. So here's the same idea. How far I want to go, divided by how many classes I want to use. Now here's a big note to take right now. You can use between 5 and 10 classes. Normally you use 5 or 6 for smaller samples, 7, 8, 9, 10 for bigger samples. There's actually a formula for it, but it involves funky-ass ratios of logarithms. I'm not going to go there. For us, we're almost always going to use 5 or 6 because I'm not going to give you 800 data points on a test or something. That would be just a little more evil than I am yet. Right.
My teacher did that.
Maybe 10 years from now, I'll be like, 800 data points. You know. I don't know. So let's use 5 classes here.
7.6, and we round it up to 8
Beautiful.
classes.
No matter what answer you get here, if it's a decimal answer, you round up. Because if I round down, my classes won't cover all my data. You want to over cover. That's why this guy could have been 60 years old. So why does it go up to 64? Just so all the classes have the same width. So all my little rectangles I make are all the same width. So it doesn't look like I'm cheating. So this is 7 point blah, blah, blah. So you round up to 8. So I want my classes to be 8 wide. I got a little handout that's kind of got this on it, so hopefully that'll help out. So so then I'm going to make something that looks just like this now for that data there. So what's my first class start at? 21. That's crazy. What's the next class start? Class start.
29.
29. 8 away, right? So where's this one got to end? 28. So everybody see the logic. I'm going to show you another way to do this, which makes a hell of a lot more sense, but it uses inequality symbols and it uses X, and that freaks people out. So this is the way the book does it. I'm going to show you a better way to do it. I don't care which way you do it. They both are fine. So one way I do this is I get the first number down at 8, at 8, at 8. So you just keep adding 8, 37, 45, 53 until you get 5. And now these are going to be 1 below that. Or just keep adding 8. Keep adding 8. Keep adding. All right. Does everybody have a home? Everybody have a place to go? All the data? The highest one is 59. It's going to go into that last class. Yay. So if you see a data point that doesn't have a place to go, you have done something wrong. Hopefully that makes sense. Does everybody get that? So this is how you see how wide they are. So they're 8 wide. So plus 8, plus 8, plus 8, plus 8. And these have to be 1 down from those so that they don't overlap, so they don't have somebody double counted. Now, real quick, just in case you're curious, the other way to do this, is that guy still going? Mm-hmm. The other way to do this, let me put this in little parentheses here. So you don't have to do this, but if you want to, the first class would be 21 less than or equal to x less than 29. Why is that allowed to be a 29 and so is this? Because does this one include 29? No. And this can handle decimal data. You don't want to see what this looks like if you have decimal data. Oh my God. Where would 28.2 go right now? Nowhere. So you'd have to take these numbers out to decimal place. Oh my God. Here, this covers any way it wants to look. Right? This is so much better. I wish textbook would teach it this way. This is the way I was taught. And again, you're not going to get brownie points if you do this. Right? If you do either way, I don't care. They're both acceptable. 29 less than x less than 37. You can see 8 this way also. That's nice. This is going to suck in a minute when we do the graph because I'm not allowed to have gaps because it makes it look like I'm missing something there. So see how there's a gap between 28 and 29? We're going to have to worry about that in a minute. People that do this don't have to. You see how I'm trying to push this a little bit? But again, if you do it this way, you're fine. You just better do it right. So frequency. I always get somebody telling me that the frequency is 7 for all of these because they subtract it. And that's not the idea. The idea is how many people are between these ages. How frequently is somebody between these ages in my data? How many people are aged 21 and 28 in my data? 3. 1, 2, 3. Right? Do you guys see that? Is that all right? Mm-hmm. Some of you guys are like, yes, I see that. But I have to do that because some of you guys are like, what the shit is going on? 29 to 36, anybody 29 to 36? Yeah. So that's going to be an allowable gap. There's going to be no bar there because there's nobody in that class. 0.